Tonight's lesson is the first of two movies on chemistry in industry. Some overall ideas just to make sure we're really clear on the fundamentals. Industries exist to make money for their owners. Never forget that. Unprofitable industries fail and close, and all the people they employ are now out of work. Successful companies make products that you and I purchase, and the money that we pay in goes to making money for the worker owners, as well as paying worker salaries and everything else that that company has to pay for. Pollution has only become an issue recently, and when I say recently, we've dealt with pollution issues over the centuries in various ways, but it's becoming much more common as an issue. And the reason why is the amount of chemicals entering the environment, as well as the type of chemicals entering the environment, have increased to the point where they threaten our way of life and the lives of other living things. Reducing and managing waste materials is becoming increasingly important. So many of the issues we're going to talk about over this movie and the next one are going to focus on certain industries as examples of ways that we can identify pollution, find ways to minimize that pollution, so that our lives are better. Moving on in 3, 2, 1. First, let's talk about catalytic converters. Internal combustion engines, like our cars, trucks, buses, all that kind of stuff, don't use pure oxygen, they use air. Some of the nitrogen in that air is unintentionally burned, and the reaction produces NO gas. So NO gas is this gas on the left-hand side here. And what happens is it then reacts with oxygen in the air to make nitrogen dioxide, which then reacts with a water molecule to make nitrous and nitric acid. The above reactions cause acid precipitation. So the use of an internal combustion engine using air will lead to acid precipitation. When we install a catalytic converter in a car's exhaust, the following happens. That NO gas will react to form nitrogen and oxygen. That happens if the catalytic converter contains platinum or palladium. And so these metals are reusable because catalysts are reusable substances. Platinum and palladium are both rather expensive, but they aren't needed in high quantities in order to do the job. So the simple addition of a catalyst in the exhaust system has greatly reduced the amount of acid precipitation our vehicles put out. So one could argue that this is a success story with respect to this aspect. It does nothing about the carbon dioxide emissions, but at least it cuts down on acid rain. Moving on in 3, 2, 1. Lead acid batteries are our next topic. Thought we'd stick with cars for a while. The most common car battery is currently a lead acid battery. Only more modern vehicles that are using hybrid technology or like a Tesla are using a different type of battery, but most vehicles which use internal combustion engines have a lead acid battery. When we return it for its deposit, the battery is going to be dismantled and different pieces get used for different things. The plastic cases are ground up into pellets, which can be used to make new cases. The lead and the lead oxide will be recycled to make new lead and lead oxide materials for the batteries. The acid will either be refined and recycled in order to make new batteries, or it can be neutralized and used to make a variety of other products, including detergents and glass. This is a great success story. We need to consider more things with deposits if we want this type of response. Moving on in 3, 2, 1. The thermite reaction doesn't have to do with cars, but there are places that don't have reasonable access to electricity, and often in historical times and even modern times we tend to put railways through places in the middle of nowhere, and the thermite process can be used to weld railroads together. So those iron pieces that the actual railroad cars ride on. They have to be welded to one another, and we can weld them using this process. The reaction is a single displacement reaction between aluminum metal and some metal oxide. When we're doing this for railroads, we're talking iron oxide. The reaction proceeds like this. 2 aluminum and 1 iron 3 oxide makes 2 liquid iron and 1 aluminum oxide. The liquid iron then can be hot enough to weld 2 pieces of iron together. The liquid iron will weld the tracks together. Now, the process releases a large amount of heat energy. Remember, it's liquid iron. Iron melts at a little over 1500 degrees Celsius, so there's a lot of heat released. So it's not an ideal reaction in some situations. A lot of times nowadays the reaction is done mostly as a demonstration, but it's a rather dangerous one because of the sparks flying and the energy associated with it. If there's time, you might want to have a look, or if there's time in class, we can have a look at YouTube where they have some examples of this. Moving on in 3, 2, 1. Magnesium mining. Magnesium mining is quite unusual compared to what we think of as mining. Magnesium is actually easier to mine from ocean water, since it's the second most common metal in the water, only after sodium. So what they do is this. Calcium carbonate, which is limestone, is heated up, and that produces calcium oxide, which they then dissolve in water. The calcium hydroxide, when added to seawater, reacts and precipitates magnesium hydroxide, because magnesium hydroxide is less soluble than calcium hydroxide. So adding soluble calcium hydroxide precipitates magnesium hydroxide. Once that's done, the product is neutralized with hydrochloric acid, making magnesium chloride. Lastly, electrolysis releases the magnesium metal and chlorine gas. So the people doing this process can get 2 useful materials, magnesium metal and chlorine gas. That's the end of the first part of this movie. The second part will deal with the other applications of chemistry and industry. Thanks for watching.